Hello and welcome back to an Walk YouTube channel video. In today's video we're going to be talking about the same Leetcode concept I talked about probably yesterday in the previous video, and that's going to be how to kind of batch problems by a specific topic. So today we're still talking about 2-pointers, and we're going to talk about 3 more problems that I've completed. So I hope you enjoy. Make sure to like, subscribe, and comment your favorite thing about the video or how I can improve my code. So first of all, let's start with intersection of 2 arrays. Given 2 integer arrays nums1 and nums2, return an array of their intersection. Each element in the result must be unique, and you may return the result in any order. So, the ideal way to do this, simple way, we would say example 1, 1, 2, 2, 1, and 2, 2. So the only common element that they have is 2, and we want it to be unique, so we'll only have one element. But I guess the simple idea is to make 2 sets. So we have set we would just say nums1 equals set of nums1 and nums2 set of nums2. So which should basically remove all the duplicates. So for example, in this list we would only have a list like so, and in nums2 we would only have a list like just containing 2, and then we would just get the intersection of both of them. So I'll just say something like, I don't know, something like that, just for a sign. That's the quickest way, but I went about it a different way without using sets. So let's take a look at that. So first of all, we define a result list, and we're going to sort both the arrays. Let's take a look at example 1. So we're going to sort both the arrays. And here are our 2 sorted arrays, N1, N2. And then we're going to say that I and J are both 0. So this is going to start, it's going to be I. Actually, I can do it with a different color. Do blue. It's going to be I. It's going to be J starting on this side. So basically my idea is that, okay, right now it's at 1, right? The ith element, so we're going to increment I. Okay, and still this 1 is less than the first element. So we're going to increment I again. And now 2 and 2 are equal. So in the res, we're going to add 2. And then maybe there's other elements, but in this case, right, after we find an element that is equal, then we want to remove the duplicates. So we want to skip the duplicates, so we want to iterate our I and J values to go past those duplicates, and they'll both be out of the list. If you take a look at the other example, we have 4, 5, 9, and 4, 4, 8, 9, 9 after sorting. So N1, it looks like an L. N2, right? Then we're going to initialize I and J. I and J. So now I and J are equal. So we're going to say, okay, great, let's go to the next I value here. Add it to the res first. So 4. And then increment the I. And then keep incrementing J so that these 2 are not equal. So we're going to go to 8, the end of everything. We're going to go to 8, and then we're going to see that 5 is less than 8, so we're going to increment to 9. And then 8 is less than 9, so we're going to increment J. And then we can see that I and J match, so we're going to add it to the res, and we're going to skip the duplicates. I is just going to increment the outside the array, and so is J. J is going to skip the duplicates and go outside the array. Our res is going to be 4, 9. So that's the general idea here. So we can say, oops, hold on, let me get. So obviously the sorting, sorting does this. Yeah, it makes the sorted arrays. And then I and J. And then we want to make sure that the I is in the range, and also J. We want to make sure they're both in the range, because then we don't have to worry about, say, a minimum list or something like that, or one list being less than the other. And then we say increment I if it's less than the current jth element of nums2, and vice versa. Equal, add to list, and skip the duplicates. So here we check if they're equal, and we add to the list, and then we skip the duplicates. So for example, here, this portion here is covered in skipping the duplicates. So first of all, when we find when two numbers are equal, we're gonna add I, we're gonna increment I and J, because we don't need to evaluate those numbers anymore. Then we just want to say, while, first of all, I must be less than the length, and also I, the current element, must be equal to the previous element. If that is true, keep incrementing. Same thing with J. And then the last two statements, if for example, said if we were at 5 and we were at 8, right? So this is just saying if nums1 is less than nums2 at the current element, right, I and j respectively, then, okay, nums I is less than, the ith element is less than the jth element, increment I. Same thing with j. So now that we've done this problem, let's go to our second two-pointer problem. We're going with 3 today, and this is going to be intersection of two linked lists. And the idea of this, or let's read the question, given the heads of two singular linked lists, head A and head B, return the node at which two linked lists intersect. If the two linked lists have no intersection at all, return null. Okay, we can see in the example A1, A2, B1, B2, B3, they both go to C1. So we can see in an example like this, right? It's not necessarily dependent on the value. So we say 4 goes to 1, goes to 8, and then 5, 6, 1 goes to 8. Now you might expect something like both going to 1 from here, and then this wouldn't be here, and then it would go to 8, but it actually doesn't matter about the resultant kind of value. Does that make sense? Yes, that does make sense. It doesn't matter about the value, it matters if the two nodes are equal, if the two addresses are the same. So I implemented a O(n) squared solution. However, I have found a better solution in the examples, or when checking the other examples. So we have a hash set Java. So let's say, or let's just make it called HS. HS equals a set, right? Set. And we're going to say while head A is not equal to null, node scene.add head A. And then head A equals head A.add next. So for example, we had example 1 here. Our set would be 4, 1, 8, 4, 5. Actually, no. Actually, yes, because it doesn't matter about the values, it matters about the addresses. So instead of writing 4, I'm going to write something like this because they're node objects. So 1, 8, 4, and 5. So these are all node objects. So I'm going to say type ln for list node. Then we're going to say while head B is not equal to null, if node scene.contains head B, return head B. So for example, if we had 5, right? So we would say 5 is not in here because this 5 does not have the same memory address as this 5. And then we're going to keep going through. 6 does not have any of the memory addresses here. 1, same thing. You might see the same value, but it's not the same memory address. However, 8 has the same memory address as this one right here. I can make get. Can make that a different color. I could say this 8, right, has the same memory address as this 8. So it's going to return this node of the intersection. And then it's just going to iterate through head b equals head b.next. And what am I saying? What is this? Oh yes. If we iterate through and we don't find a node, then this is just going to be null. Because while head b is not equal to null, this will mean that break is going to be head b, points to null. So it's going to return null here after everything is said and done. So I thought this was a better solution than what I had come up with, minus on squared. This is simple, just on. This on squared solution is not very efficient. But now, let's take the same idea and go into another linked list problem. This is remove nth node from end of list. Okay, so the idea is, given the head of a linked list, remove the nth node from the end of the list and return its head. So 1, 2, 3, 4, 5, n equals 2, we get 1, 2, 3, 5. So the n values is the distance away from the end of the list. So I guess the end of the list is here. So like end. And so this is 1 away from the end. This is 2 away. 1 and 2. And then so on 3, 4, 5 away from the end of the list. And we want to return removing this list. We're removing nth node from the end of the list. So if n is 2, then we know this is 2 away from the end, and we want. So we'll see there's no 4 here. So the idea is, I saw in the hint, maintain 2 pointers and update one with a delay of n steps. So let's say we have 2 pointers, and let's say we have p1, and let's say we move n times. So the first example, it would be 2. So we go 1, 2. So this is p1. So the hint says the 2 pointers and update one with a delay of n steps. After we've taken n steps, then we want to initialize a new pointer called pointer 2. And now let's kind of advance both these pointers and see what happens. So if we say p1, actually this will be the secondary advancement in pink. So p1, p2, p1, 2, p1, p2. And we realize that when p1 equal to null, we have the p2 has arrived, the correct index to remove. So that's the general idea here. So let's see this. Basically the base case, first of all. You can look at example 2, right? So head is 1 and n equals 1. The idea is that you would just return null because you'd have to remove the first node anyways. We can see here in the constraints the number of nodes in the list is sz, and n has to be in that range, 1 to sz. So if there's one element in the list, it has to be 1. And so basically if the head.next is null, that means that this is head and that's the only element. So we're just going to return null because we're removing that element. Okay, so in its normal pointer, this normal pointer is p1, 1, and then we're going to say while n is greater than 0, say normal was normal.next, 1, next. And that's going to get us to be here, right, at the end of this loop. I can say this gets us here, right? And now we initialize a delayed pointer to move until normal equals null, right? So we say delay equals head, we start at the beginning. And then we say that the previous node, right, for deletion, because we're trying to delete a node, so we need the previous node, it's going to be null. So we're going to say while normal equals null, we're going to move normal. Previous is going to be set to delay, or delay. So after this, normal is here at the null position, and the delay node, E2 is here This is P2 delay. So that delay node is going to be located at 4. And then we're going to say remove the current node. So in example 3, we see another base case. Or not base case, but a special case. So if we're removing the first node, so for example, it's n equals 1. So 1 away from the end is 2. So when we try and set previous.next, because previous is null, right, before the list, because we would, wait, yeah, because since the next iteration would cause normal to be, what am I even saying? Hold on, I need to go through this. So for, this is removing the first node. Oh, sorry, this is the case for, if we say 1, 2, n equals 2. So we want to remove this node here, because that is 2 away from the end, right? 1. And, to the null is 2. So that would be when prev is not equal to anything, it's a null. So we're just going to say head equals the delay node, right? Because the delay node is at the node that we want to. So the delay node would be here. Then we're going to say put the head equal to this next node. And then whatever elements come after that is fine, because the head is equal to this node, and then, that has a pointer to all the other nodes. So that's the general idea of this problem. Remove nth node from end of list. So I hope this was a better video in showing how you can use this two-pointer technique, and you can even batch it further into linked lists, for example, or other types of problems like strings or arrays, and you can get better and improve and start to solve those medium problems. I hope you enjoyed this video. Thank you very much for watching. Pewalkie out. I should define my OBS.